In this case, we can use the straights as a control for the turns. So all we're looking at is not absolute values, we're just looking at differences between the straights and the turns. The other advantage, of course, here is we're not changing the mass moment of inertia of the hoof. We can do this at a gallop, you can do this at full speed. It was about 95% full speed, but you get the idea. And they were halfway between the coronet band up here and the wear surface, so it's well up, so it's in the area as far as you can see, minimize laser pads. Okay, so what happened? And they travel both clockwise and counterclockwise so that you can see the comparison. There was no significant laterality to the loading, but they did have they each within a hoof. What was the only thing that was statistically significant on the turn was the strains on the inside of the hoof versus the outside of the hoof. So you couldn't tell the outside from the inside, but you could tell the outside of the hoof from the inside of the hoof. This really suggests that a storytelling. It doesn't seem completely logical in a way, because you'd think that you'd be using something on that, but I think it has to do with running at full speed. There's a lot of work with, there was some work clear back with cheetahs, and that's why they have to change lead, is to get around the corner. And so you're going, most horses or almost all horses in the US, they start in the right lead, out of the gate, they change lead to the left lead, going through the turns, change back to the right lead on the straights. Okay. This probably also is related then, because we've got this difference between synthetic and turf, we also have very different shear strengths in the surfaces. Well, this was some work by a couple guys at Royal Veterinary College that talked about traction limited versus force limited turning. This looks like if anybody knows anything about auto racing, you know, you can over-tire a car too. This is a car that's over-tired, has too much tire. This is one which has too much engine. You know, so you can either be traction limited or force limited. And so what happens is, probably what's happening is, on the dirt tracks, they're probably traction limited. They're making their own banking, but they're insufficiently able to get a hold of it to balance that. So as that suggests, it's altering the loading on those limbs. And the thing is that they're not able to get the moment, to produce the moment in there to support it. It also suggests that switching between surfaces might be a risk factor as well. Okay, so traction limited surface, your ability to balance the load between the limbs is limited. And then the other thing that we've seen, and I'm not going to go into it here, but I'll say verbally, we've also seen something that's very counterintuitive as well. It goes back to the comment about Miner's rule. It turns out the tight radius turns, the tracks with tight radius turns, do not have a higher catastrophic injury rate, or do not have a higher rate of laterality of injuries. What does that mean? That probably means that turning is an exposure variable, that you've got a certain number of turns in your life. Even if you're traction limited, especially, you're using maximum load regardless of the radius of the turn, because you're not up there. You're not up there in that force limited range. So if you're traction limited, what you've got is you've got a certain number of turns. This is where it's exciting to take the application, the theory back to the applications. You say, what do? Are you going to change all the racetracks? No. The simple thing would be to never train a horse around a turn. A lot of racetracks, you can do your fast works without using the turn. Or if you do, you do a one-turn mile instead of a two-turn mile, like you can do a one-turn mile at Arlington or Churchill, and you minimize the two-turn miles where you have to turn around two turns because you got a certain number of turns in that horse, and it's a risk factor. So again, if you think about it in a model of public health, it's like, what do? This is a minimizing the risk. You know, so seatbelts for horses. The idea then eventually would be to get dirt safety closer to the synthetic or turf. So everything we can do to bring this together helps. We're not going to go back to synthetic. There's not the money. There's not the will. There's a whole lot of other factors in there. But there is the opportunity to look at the other factors. But it all has to do with tying this mechanics back to musculoskeletal disease. So the horse leans on wide transition. Their bilateral loading is not significant. There's a lot more adaptation at faster gaits. The effect of banking is likely to depend on the surface. What's interesting is you can get away with more banking on a synthetic surface. Would you do it? No. No bother. There's not laterality of injuries. It's probably pretty good by the way it is. All right? And the condition of the surface obviously will impact the biomechanics. I don't know if you've ever seen this. There's weird things in horse racing all over the world. Visit the Swedes. They race thoroughbreds on snow. And my Swedish colleague, he was commenting about a surface he really liked. He said, oh, it had a good responsiveness. It was almost as good as our pond. So, but you know, it's all cultural. You know, so part of this is always going to be these changes. And you know, certainly this is true in all kinds of agricultural applications as well. You know, there's all kinds of thinking in that, and then at some point you just got to address the cultural issues. Okay, I'm going to take a couple minutes now and talk about some of the future work. There's a lot of work I don't do in Maine because Maine. I work with aquaculture in Maine. Aquaculture is there because aquaculture belongs in Maine. Obviously, Kentucky, if you look at the license plates, it's pretty clear the horses belong in Kentucky, and it's so much of the identity of the state. Some of the things that have become just huge in the industry is Bill Kasner at the Welfare and Safety Summit gave an impassioned talk about ventilation in barns. It's an oftentimes a design issue. There is, you know, you're bringing the air in from the bottom, maximizing the airflow from the bottom, taking it out the top. If you've got dust on the bottom that's coming from feed, what are you doing? You're maximizing the amount of dust that's aspirated and particulate matter that's aspirated on the horse. Horses are not like us. I mean, people talk about interval training and such. They're limited by musculoskeletal disease. The other thing is bleeding. And so if we talk about respiratory health for a horse, it's way up there on the list. And it's something that hasn't been addressed. One of the things that's a no-brainer on this, that's again sort of the simple issue, like not training on 200 miles, is steaming the hay. You can reduce the amount of particulate matter in the air pretty dramatically that way. But the idea here is to look overall as this is a part of the respiratory health of the horse. Racetracks are treated like feedlots from a legal standpoint, and it's actually useful to think about them from that size. What's unique about racetracks, it actually has the potential to help overall animal health, is your average hog farm does not have a value associated with each of the hogs that looks like the horse, the value of a thoroughbred. You know, if you have livestock that's worth $35,000 a head, you can begin to pilot stuff. In the business literature, it's called skimming. You know, you take the people who don't care as much about price, you do that, and you look at that strategy, and then move down to other applications, because scale, of course, gives you opportunities to do it. But in this case, it has the opportunity to deal with what is probably a key issue with horses. I haven't done any work with that. It would be great, and I understand you got a couple new people coming in who may have some expertise in that area. One of the things that I did a number of years ago that I haven't done anymore is we had a little bit of money from National Institute of Occupational Safety and Health on slip, trip, and fall, looking at unimproved surfaces. Again, you talk about risk factor in construction. It was number 2 in construction, not right behind auto accidents as far as risk to lost time accidents. If you talk agriculture, it begins to be huge. Well, it's again this biomechanics. It's actually the same traction issues you're talking about. And one of the things that we had funding for initially at that point was adding fibers to the surface to increase the traction when it's wet. Riding equipment. You know, it's everything from the breakaway reins to the the helmets, which is probably belongs somewhere else. But there's this consistent pattern where a lot of the equipment associated with horse racing is adapted from other applications. It's actually an opportunity as well because it goes way over to the equestrian sports side. And obviously the ventilation in barns, I was focusing on racing, but that's if we actually talk a much larger issue when we start talking sport horses. What you've seen here too is this is something that's become very common in Germany. And in Germany, most small towns, rural towns, have a town riding arena in the center of town, or towards the center of town, shockingly close to the center of small German towns. It's paid for essentially out of health money. It's subsidized. They'll have a hockey arena and they'll have a stable because it's a different population that rides horses than plays hockey. And actually the comment I got was the equestrian facilities were actually cheaper to run than the hockey arenas. And there's a big gender difference between it, and there's an age difference. And it was one of the things that it was a way of keeping women who were later in life active and participating in the sport. And the horse was the glue. And actually this is one of these things as a mechanical engineer, the least diverse of all engineering disciplines, although we go neck and neck with aerospace, I think. I forget what the other one is. The gender piece on this is huge, because the horse thing brings things into engineering, brings aspects of it that don't exist. So anyway, going back to these German stables, these are active stables. Horses are really happy in a group. They're herd animals. They leave them in this active stable. You know, you gotta deal with stallions are always the problem, but that's true in every group that you have to deal with stallions. They self-feed in these units, a microchip in their ear. They get to eat. You can control the amount of food each horse in the group stabling has. So you know, you got some people with an eating tendency, and others that don't. You may have heard about the labs. Did you hear the thing that they're genetically not responsible for the fact that they can't quit eating? Yeah, wasn't it? I love that. But I mean, you know, we've got some of the same issues in the horse population. I'm sure some of them, you know, they just don't know when they're full. You know, so this is the way where this is addressed directly. This isn't done at all in the United States. From an animal health and welfare issue, it's huge potentially, and this is one of the things that would be really interesting to bring in. Again, made no sense. They actually talked about working to donate one at UMaine, and we have 12 standard bred mares that are lame and off the track. And I said, you know, this is not in the population. You want to demonstrate this to the world of horses in the United States. And then, of course, small-scale energy efficiency, where we've done some work with farms and stuff. The other thing that I am passionate about and have not done in Maine is linking biomechanics as a link to foundational mechanics. You look at that turning thing, you know, to an engineer, if you're good at dynamics, you have a decent dynamics background, you say, of course, you can take it as a center of mass plus a rotation, you add it up, it's energy, it adds up, we don't care about coordinate systems, we can just add it together and it's easy. That's a pretty subtle concept, you know, and you think about teaching Lagrangian mechanics, it also allows you to deal with some pretty difficult problems very quickly. This Professor Williams at MIT wrote a book that I've used at a 400 level for mechanics, and it's fundamental applied dynamics, and he has Newtonian mechanics for one chapter, and then he moves over switches right over to all to energy methods. Well, it was actually interesting because conceptually it was much easier because it was kind of a cookbook process. Bringing this to horses, dogs, and sports make this a much more approachable topic. It's a tool for understanding fundamental issues in injury prevention, talking about that, but it also turns out that it's a nice way to reinforce the foundational mechanics, which is the best thing about a 400 level class as far as I'm concerned. You take a 400 level course or an introductory graduate class, and you take it, and if you can reinforce the engineering science, the 200 level engineering science at that point, that's probably the stuff that the students retain as they go forward. Because that's, you know, you get it the second time. You know, you might not understand thermodynamics until you take the power plant class, because at that point you did it enough and you applied it to something. So, if we talk about, you know, ways that, you know, one of my long-term dreams is tying this back to, you know, biomechanics of horses. The other thing that I've actually done a fair amount of work with on this, using this as an example of sports, you know, again, it's easy to think about it, that the pivot movement in football and soccer, this is quite critical to, that's where the ACLs, the MCLs are blown out. And again, you'd be shocked at the way they measure that in soccer and football. American football, there's no standard for it at all on fields, even at the NFL level. Soccer, FIFA has a standard which involves a cleat dropped with a weight and a torque wrench. Swear to God, you can't make it up. On a nonlinear strain rate dependent material, and multi-million-dollar athletes who are most likely to, one of their most likely reasons for retiring is an ACL injury. It's like, and that's technology. But this all comes back to the same set of core skills. It's dynamics is what you're looking at. And then finally, the broadest impact is people. This is a group that worked in the lab two years ago. These are some of the people who graduated. Tamara's just started General Motors. Ellen is actually on maternity leave right now, but she's going to be teaching at Swedish University of Agriculture. John Bridge is a associate professor now at University of Washington. Maureen is a equine physical therapist, and her PhD is actually in microbiology. She did not work with me, but she worked in the lab. But it's really the people. I mean, it's like anything else. And then Becky gets particular note. She was the horse person who, clear back when I was in CSU, introduced me to Wayne McElrath because of her passion for horses. Her honors thesis was actually on shoeing, and her master's thesis was on mass moment of inertia of Bob. Bob was a paint horse who was used for research. Each of her limbs was that. That's the broader impact. One other thing, always on the outcomes of publication. Kind of interesting where this stuff goes. Our philosophy on this has always been to vet it by that, no pun intended, to vet the material not only in the applications literature, but we also go back to the core literature. Acta Thermochemica is Wayne McElrath, who's an orthopedic surgeon, laughs that he's got thermal chemistry papers. But the idea is the thermal chemistry that we were evaluating, we needed to get the analytical chemists to sign off on our methodology before we were willing to tell the horse racing industry that we knew everything we needed to know about waxes. So this was part of John Bridges' PhD. And then the acknowledgments, the way I fund this is building relationships with racetracks. I mean, there's no big funding revenue channels for horse racing. What there is there's a $10 billion industry, and I told my colleagues at one point that horse racing is about the same size as Lockheed Martin, but there's a lot fewer engineers to compete with. So thanks, and I have to make sure this will give you something to look at as we start some questions. This is done at Keeneland, and this was Markerless, a demonstration of Markerless tracking of the hoof impact.
And that's a normal hoof, right?
Yeah. Normal hoof.
Wow, it really bends.
Oh, the fetlock, isn't that just incredible? And it's just amazing because you've got essentially the suspensory apparatus that goes around there, and the fetlock goes all the way down in, but it's a spring damper system.
It's not bearing weight though, right?
Yes, it is.
Is that what it is?
Yeah. Well, it's the suspensory apparatus that goes around behind. The springs that go around actually are carrying the load.
Okay, yeah.
Yeah, go ahead and try and build a mechanical system that do that. It is so much a no-go. But yeah.
Pretty amazing. Well, let's thank our speakers. Do we have questions for him?
Question?
Yeah.
Do the legs basically break on the horses break in the same place pretty much?
There's a couple really popular places. The second actually let me go back. I can show you the worst ones. Okay, so there's I should preface this. There's the common chips and stuff that are quite common. If we go back. I had a leg. I'm sorry. Oh, there we go. You get a lot of chips right down here. So you can picture that. You've got high heavy loading, and what's happening is there's a lot of bone remodeling on the articulating surface there. And it is you can model it as an inclusion. It looks just like the Eshelby inclusion in a anisotropic material. very anisotropic in that region, and so what it'll do is remodel as it builds up, and then that hard area that excessively remodels, that's actually the fracture initiation site. So basically, but if you, what happened, what finally killed Barbaro was not remodeling, when they get laminitis, when they can't be weight bearing. So you know, it's like vitamin C, you gotta have some, but you can also poison yourself with it. And so that's where and so you'll get fractures there. But like, you'll also see the cannon bone that'll blow up. And I'll tell you what, from a public relations, you know, I mean, if you're not sick to your stomach when you see that, it's just like, you know, you're gnarly. It's a classic compound fracture. There's no meat around it, right? Essentially, it's just a suspensory apparatus, and so it just.
Are all these fractures always fatal? I mean, have
No.
No. Just the cannon bone fracture?
No, and there's some really neat work that a colleague at Kansas State has done, even with early, and I don't remember the right word for it, and I'm guilty of this, the holes that are in the bones on the juveniles, you know, they have it on children as well. She put screws across, and some of the veterinarians were making fun of her because she just run a screw right through the hole. Well, if you think about what it's doing to the stress field, what is it going to do? You're going to increase the stress concentration in that. You're going to stimulate the remodeling. It stimulates the remodeling. It fills it in. You take the screw out, and it's already starting to fill in. It's like this looks so much like engineering something that's going to readapt that it's not even funny. And so she after they were making fun of her and everything, there's now a few people, including one at Reuben Riddle, who started to experiment with it. So Wayne McElraith, who's an orthopedic surgeon that I work with, he made his reputation on probably more than anything else on a derby horse where he removed chips 6 months before a horse won the Kentucky Derby. There is with this bone here, there's you know, it's the classic screws across, get it to remodel, but they usually never race again. You know, and that's a second career or a field accessory, you know, something to accessorize your front yard. And actually, the other one that's a problem, of course, is the soft tissue injuries are very difficult to recover from. You know, I mean, think ACL injuries in football.
But they don't euthanize them for that.
No, but oftentimes it's really difficult to find a second home for them because that second career falls apart. You know, if you can't. So.
You can't ride them.
Yeah, you can ride. You know, I mean, you can. You know, somebody who just wanted to go out and ride around the pasture would be probably fine. But you know, just not to compete with them.
We're talking about banking on the turns. I never thought of that. Are horse tracks banked at all?
They are. They are. So what's typical, and there's the two types of banking. What's typical in the dirt tracks would be about 3 to 5% on the turns and 1 and 1.5% in the straights. 1 to 1.5% in the straights is just cross falls. When they seal it, it'll water run off to the inside, and then like I mentioned, the Fair Hill Training Center is at 10%. This all came to a head though when they started putting in the synthetic tracks because there was a engineering firm from Lexington that started putting in tracks in all over the country, working with Jim Pendergast and the folks out at the Thoroughbred Center. They went out, and it turned out that the tracks they were installing were not even complying with regulations in California. They had regulations on it that was based on just what they'd always been doing. Nothing better than that. And actually, you know, it's not a half-net approach because you think about it. The banking really serves a purpose, but probably what's the bigger risk to the horse is changing lead, because there's a big bobble, especially with some horses with maybe a less balance. There's a big bobble when that happens. What I tell people when they ask me about traffic banking is that, or the transitions, that where they put the transitions is that you should do whatever the local tracks are doing or wherever the jockeys are going to, because the jockeys are probably using that as an indicator to help guide the horse to change lead. The horses are probably used to changing lead with a certain balance. So just don't be weird, and then we'll work on trying to find out how horses. In the meantime, we'll keep working on basic science. But and really, the upper limit on that is basically how much you can keep the. You know, you can bank it a lot more, but you can't keep the material up.
When you say changing lead, what do you mean? left foot goes right?
Yeah, so,
And they changed that?
yeah, so, horses, it appears there's nothing in the literature. Actually, so the same Becky Woodward who got me into horses, who also got me working with whales, she actually published a paper on laterality in humpback whales. Humpback whales, 80% of them are right-handed and 20% of them are left-handed. They look just about like humans. You can tell because the wear patterns are balleens. Cats are about 85%. It's published that they're about 85% right-handed. So when they're sitting up there on top of the refrigerator knocking things off, you watch them, you've got an interesting cat if they're left-handed as they're knocking the pencils off the top of the refrigerator, okay? There's no reason we'd expect neurologically horses to be different, and it's probably more likely that they'll show more of this laterality in their lips, because that's neurologically a lot more like a hand to them. So there's actually a study I'd love to do where sorting feed, because they'll have preferential feed, they can use their lips to sort feed, and so with a video camera, you could probably tell how many horses were right-handed. That's a long answer to the fact that horses in the United States, this isn't true worldwide, and the horses in the United States, they pretty much train them to come out of the gate on the right lead. And probably makes sense because they're right-handed. But we turn left turns.
Why don't they run in the other direction?
They tried at Tampa Bay Johnson. Their insurance agents said, no, they're going to drive them crazy. In Maiden, in the Middle East, they do. Every other day they do the opposite direction. United States, you know, it's like that old motto. We've always done it that way.
Are there less injuries when they run in the other direction?
It's hard because there's so many other factors. You know, that's an excellent question. And it comes back to this laterality. And it's kind of one thing that's kind of nice is we've got this natural experiment we're running, right? Because from the academic in me says, yeah, we can learn from this. If we're wrong, we'll have to do something different. But in England, they just run all over. You know, I mean, they have these different courses. It's almost always on turf. It's like at Ascot, they'll run 8 races and they'll never go over the same ground twice because they have these different courses that are laid out, all in kind of a layout. So going all the way back to the initial question, which is now completely forgotten.
Does the horse change?
Change lead. That's
During the race, did you say?
Yes. So they're right-handed, they're going to come out of the gate, and even if they are left-handed, you train them to be right-handed, like they used to do the kids that they teach them to be right-handed. So they're right-handed, come down this backstretch, let's say they're only going through one turn. Then to get around the turn, they switch to the left lead, because that's going to be what's rotating them around the turn. And this is this paper back in the 70s where they did cheetahs and horses, and they showed cheetahs, if you give them food, you know, when they make the turn, following prey, they'll be running along the right lead, they'll change lead to get around the corner. Kind of makes sense if you think about the mechanics of it, but so they're all changing lead. But then what they do is, almost all of them change back to the right lead on the front stretch, which probably is a waste of time, right? But if it's an endurance issue, and keep in mind that they're not aerobically limited unless they're leaders. Their hearts are big enough to do just about anything they need. What they're really limited by is their musculoskeletal system. So there's probably some logic to going on the right, left, right, and then balancing it out. But it's just done that way it's done that way regardless of what